Let's take a look at the Johnson counter implemented in LabVIEW. A Johnson counter is a shift register with feedback. I'll show a 4-bit example here. Each one of the clock inputs on the flip-flops connect to a common system clock. The flip-flop outputs and inputs are wired according to a write shift register. And then rather than discarding the rightmost bit, we invert it and send that back around to the D input on the left side. Let's take a look at the LabVIEW implementation with feedback nodes. Each feedback node corresponds to a single D flip-flop. Here's the inverter right there, and you'll notice that we have a direct correspondence between the original schematic and the LabVIEW diagram. Again, one of the pluses of the feedback node, so it looks exactly the same. An equivalent version is based on the LabVIEW shift register. Now here I place only a single shift register, but you'll notice that we have these additional terminals showing up. These are placed by choosing the add element option from the shift register. And these retain values from even earlier iterations. So that's actually fundamentally where the LabVIEW name shift register comes from, is that does in fact implement a shift register directly. We see the characteristic pattern here. To get just a little bit better sense of the operation of the device, consider that the values are always being shifted from left to right. If we were to take an example of the rightmost bit being at 0, that will invert to a 1 and then start filling in ones on the left side. Let's try running that for a moment. Now once this bit reaches a 1, then of course that will invert to a 0, and then we start filling in zeros on the left side.